Hello, friends, and welcome. So, here I am with another interesting and important topic, that is the OSI reference model, or we can say the 7 layers reference model, right? Because it is obvious it has 7 layers in it. And when we talk about the OSI reference model, actually it helps uh, in understanding the communication between two devices, right? Although we have discussed about the networks in detail in our previous video, that what is a network, how we can establish, what are the networking devices, what is a topology and the network architecture, each and everything we have discussed in the previous videos. But in this video we are going to target the OSI reference model. So let's start it. Friends, OSI, that is the Open System Interconnection Model, defines and is used to understand how data is transferred from one computer to another in a computer network. In the most basic form, we are taking example of two computers that are connected with the help of a LAN cable, and obviously with the help of connectors that are the RJ45 connectors, and sharing data with the help of a NIC. NIC is the network interface card that must be inside your computer or the system. But if one of the computer is based on MS Windows and the other has a Mac operating system, then the question arises that how these two computers are going to communicate with each other. In order to accomplish successful communication between these two computers or such networks, the model, that is OSI International Model, was introduced by ISO in 1984. Now ISO is a organization. The full form of ISO is International Standard Organization. It introduces a model, that is the OSI model, in 1984. It has 7 layers. From the start, we have the topmost layer, application layer, session layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. And friends, these bottom 3 layers are known to be the hardware layers, and these 3 upper layers are known to be the software layers, and transport layer is known to be the heart of this model, right? So let's discuss each of the 7 layers in detail, and here we are starting with the topmost, that is the application layer. Friends, application layer is used by network applications. Now what are network application? Network application means computer application that use internet. For example, we have browsers, that is Google Chrome, Mozilla Firefox. We have some of the applications like we have Skype, and then we have Outlook. So a web browser, we can say a web browser is running on a PC or a device. It uses application layer protocol, that is HTTP. Now HTTP is known to be the hypertext transfer protocol for web surfing, because from web browsers would go for web surfing, right? So all network application, including the Skype or Outlook, are dependent on the application layer protocols to function, and there are dozens of application layer protocols that enables various function at this layer, and some of the application layer protocols are mentioned over here. Let's go into it. Like we have NFS is the network file system. Then we have SNMP, that is simple network management. Then we have HTTP, I already mentioned that. We have FMTP, that is flight message transfer protocol. We have IRC, that is internet relay chat. We have FTP, file transfer protocol. We have POP, that is a post office protocol. So all these protocols collectively form this application layer, and these protocols forms the basis for various services. Here are some of the services, like we say file transfer, we go for web browsing, web surfing, then we have email and virtual terminal. And for file transfer, the protocol that is used is FTP, that is file transfer protocol. For web surfing, we use HTTP, hypertext transfer protocol. For email, we use SMTP, that is simple mail transfer protocol, and for virtual terminal we use telnet, right? All the application layer provides services for the networking applications with the help of these protocols, right? Then the next layer is the presentation layer. First thing, the presentation layer, it is obvious, it receives the data from the application layer. Here presentation layer perform three major tasks, that is translation, compression, encryption or decryption. So the number one task that is performed by the presentation layer is translation. Now the data received by the application layer is in the form of characters and numbers. So the presentation layers converts these characters and numbers into machine understandable binary, right? The first step performed by the presentation layer is the translation of characters and numbers into binary. For example, here I'm taking the example of ASCII to ABCDIC. Now all we know, ASCII is the American standard code for information interchange, and ABCDIC is the extended binary coded decimal interchange code. After conversion, or you can say translation, the next step is compression. Now what is compression? Before the data is transmitted, the presentation layer reduces the number of bits that are used to represent the original data. This bit reduction process is known to be the compression, right? The data compression reduces the amount of space used to store the original file. As the size of the file is reduced, it can be received at destination in very less time. For example, if the original data file size is 5 MBs, or we are compressing it up to 2 MBs, so the file reduction, the size reduction or the compression will help it to move or deliver in very less time. The next thing here performed in the presentation layer is the encryption or decryption. Now encryption is a method of coding your original piece of information in some other form, right? So encryption and decryption is being performed on the presentation layer to maintain the integrity of the data. Before transmission, the data is encrypted, right? Encryption enhances the security of sensitive data. At sending side, the data is encrypted. Obviously the data that is the data sends in the form of encryption, and then at the receiving side it is being decrypted, right? So for this encryption and decryption, the protocol that is needed is the SSL, that is Secure Socket Layers protocol. So after presentation layer, we have session layer. And before understanding about session layer, or to understand better about session layer, let's take an example. Suppose we have planned for a party. Now what we have to do, we can't manage all the thing by our own. We are going to hire a few helpers that will help us, right, ensuring that each activity runs smoothly, right? And these helpers will help us in setting up the entire party, in assisting in many tasks like cleaning, like serving, and then up to closing the party. Like similarly, same is the case with your session layer. What session layer do? It helps in setting up and managing connection, enabling sending and receiving data, followed by termination of connections or sessions, right? Like we have hired helpers, the session layer also have its own helpers, and what these helpers are? These are the APIs. Now API is the application programming interface. So session layer have its own helpers that are APIs. Let's take a simple example of API over here. Like we have NetBIOS. NetBIOS mean network basic input output system. And what this API specifically do, it allows application on different computers to communicate with each other. And how the session layer will perform its task? First thing, it goes with the authentication, then authorization, and then with the session management. And if you have gone with through my videos, you must be familiar with authentication and authorization. These are very common terminologies related to the communication, right? Authentication is identity and authorization is the access, right? So first thing, authentication, just before a session or a connection is established with the server performs a function called authentication. It is the process of verifying who you are. For this, server uses a username or a password. Now authentication has many methods, but here we are talking about the very simpler form, that is the username and the password. Once entered username and password are matched, then the session or connection is being established. And after authentication, we are going for the authorization. Now authorization is a process used by the server to determine if you have permission to access a document or a file. And if you do not have any permission to access the document or a file, simply you will be receiving a message that says you are not authorized to access this page or a file, right? So these both tasks are performed by the session layer. And thirdly, the session management. For session management, what session layer does, it keeps a track of the files that are being downloaded. For example, a web page contains text and images, etc. These text and images are stored on separate files on the web server, and when we request a website in the web browser, our web browser opens a separate session to the web server to download each of these text and images files separately. Now these files are received in the form of data packets. Session layer keeps a track of which data packet belongs to which file, either a text file or an image file, and tracks where the received data packet go. In this case, it goes to the web browser, that is SL layer, that is your session layer, helps in session management. And after session layer, we are going to discuss about the heart of the OSI model, that is the transport layer. Transport layer controls the reliability of communication through three major processes: segmentation, flow control, error control. Number one, segmentation. Now what is segmentation? In segmentation, data received from the session layer. So in segmentation, data received from the session layer is divided into small units called segment. Now each segment has a source and destination port number and a sequence number. Now the port number helps to direct each segment to the correct application, and the sequence number helps to reassemble segment in the correct order to form correct message at the receiver. Then the task, that is the flow control, is going to happen. Now what is flow control? The transport layer controls the amount of data that is being transmitted. Consider our mobile is connected to a server. Suppose the server can transmit the data up maximum at a speed of 100 Mbps, and our mobile can process only up to 10 Mbps, right? So now we are going to download a file from a server, but server starts sending the data at 50 Mbps, now which still is greater than the rate our mobile can process. So the mobile phone, with the help of the transport layer, can tell the server to slow down data transmission rate up to 10 Mbps, right? And it can go on both ways. If the server is sending data at higher speed, the our system will request to slower down, and if the server is sending at lower speed, our system can request to higher up. Similarly, if a server is sending data, let's take 5 Mbps, and mobile phone will tell the server to increase the data at 10 Mbps, because it has the capacity to process the data at 10 Mbps, right, to maintain the system's performance. Next thing is the Error control. Now for error control, transport layer helps in error control if some data does not arrive at the destination. Now what transport layer do? It uses an automatic repeat request scheme and retransmit the lost or corrupt data, a group of bits that are known to be the checksum. So it uses checksum, that are the group of bits is added to each segment by the transport layer to find out the received corrupted segment, right? And friends, transport layer performs two types of services. Number one is connection oriented transmission. Number two is connectionless transmission. For connection oriented transmission, we use the protocol TCP, that is transmission control protocol, and on the other hand connectionless transmission uses UDP, that is the user datagram protocol. TCP is used where the feedback is important, where we want the full data delivery, like we can say WWE, that is World Wide Web, email or file transfer protocol. And UDP is used where feedback is not important, where you doesn't need any feedback, or it does not matter that you have received all the data. For example, we are talking about online streaming of songs, movies, games, etc. After that, friends, the next layer is the network layer. It works for the transmission of received data segments from one computer to another computer. Data units in the network layer are known to be the packets. It is the layer where the router decides. Now it performs three major tasks, that is local addressing, path determination and routing. Now what is local addressing? In local addressing, the IP addressing is done in network layer, which is the called local addressing. Now what it is? It means that every computer in a network has a unique IP address, that is Internet Protocol address. So network layer assigns senders and receivers IP to each segment, that is the portion, that is the past, or that is the you can say the actual amount of data to form an IP packet, because the data travels in the form of a packet. So network layer attaches or assigns the sender and receiver's IP to each segment to form a IP packet, and these IP addresses are assigned to ensure that each data packet can reach to the correct destination. Now the second we have path determination. Path determination means choosing the best possible path for data delivery from source to destination, right? A computer can be connected to internet server or a computer in various ways. You can say a number of ways, but choosing the best path is known to be the path determination. Layers in devices used protocols, like you can say OSPF, that is the open shortest path protocol, and the BGP, that is border gateway protocol, right? So with the help of such protocols, it will going to choose the best path for the transformation of the data. The next thing is your routing, and routing is the process of moving data packets from source to destination, that is from even providing the route. To understand it better, let's take an example. Here we have two computers. There is computer number A, that is computer number B. It is connected to a network 1, and then it is connected to network 2, right? So it is based on the format of their IPs. We can say IPv4 or IPv6, right? So here computer number A is connected to network 1 and computer number B is connected to network number 2. And let's say that this computer, that is computer number B, requested to accept the Facebook, and now here the Facebook server rely on the computer, right? So what happened? This packet the packet that is asked from the computer, that is computer B, needs to be delivered to computer B, right? The packet that is asked, that is the requested, that to access Facebook, is actually have to deliver to computer B. For this, there are, both the computers here, A and B, we are discussing about, they are even connected, so they both have their unique IP addresses, right? So the Facebook server has already, now what Facebook server do, it has already added senders and receiver IP addresses into the packet. That package is going to be sent, right? And the packet then based on the IP addresses will received, right, by this specific computer. So the packet first from the Facebook server moves through the network 2 and then to the computer B. So based on the IP addresses, or we can say mask, the routing decisions are being made in a computer network. So the next layer is known to be the data link layer. And here, friends, there are two types of addressing that are being performed by the data link layer, and we are talking about the logical addressing and physical addressing, and we already discussed about logical addressing that is being performed by the network layer, and the physical addressing is done at the data link layer. Now what will happen in physical addressing? In physical addressing, we are using the MAC address. MAC address is the media access control. So the MAC address of sender and receivers are assigned to each data packet to form a frame. So here a frame is being created. MAC address is a physical address, it consists of 12 digits. It can be alphanumeric, right, embedded in the NIC of our computer by the computer manufacturers, right? So in this specific data link layer, the data unit that is going to be transferred is known to be a frame. In the previous layer we discussed about, they are known to be the data packet, and previously we talk about that is a session. So from session to packets, now to the frame. So data link layer is embedded as a software in the network interface card of the computer and provides means of transfer data from one computer to another with the help of a local media. Local media can include a copper wire, an optical fiber cable, or air even. And here, friends, media does not correspond to audio, video, or animation, right? But it refers to the physical link between two or more computers or networks. So here in data link layer, two functions are going to perform, that is first access media. Access media is actually, it means it allows upper layers of OSI model to access the media with the help of technology, that is framing. And second, it controls how data is placed and received from the media with the help of technologies, media access control and error detection. To understand this thing, let's take an example. Consider, friends, we have two different hosts. On one side we have a desktop and on the other side we have a laptop, right? And they both need to communicate, right? So as laptop and desktop are connected to different networks, here it is connected to network 2, here it is connected to network 1, they will be using network layer protocol IPs, for example, in this case, right? In this example, desktop is connected to router R1 with the help of a Ethernet cable. This is Ethernet cable, it is connected to router R1, and on the other hand, R2 is connected to a laptop, and this connection is a wireless connection. Now, if desktop wants to send data to laptop based on the medium used to connect desktop to router R1, that is the Ethernet cable, right? So the IP packet that is going to transmit, it is being encapsulated. That means there is addition of in the head and tail of this IP packet, and it will be converted into a frame, right? So the R1 router receives this Ethernet frame First it will decapsulate it, and then it will encapsulate it again into a frame. So it will receive the packet that is encapsulated. First it will decapsulate it, and then by adding into head and tail of it and forming a frame, it further encapsulated, and then it sends to the network with the help of a satellite, right? And after receiving at network 2, first it will decapsulate it, right, by the network, and again with at the router it will encapsulate in the form of a wireless link frame. So the laptop receives the wireless data link frame, decapsulate it, and then forward IP packet to the network layer. Finally, data arrives at the application layer, and application layer protocol then makes the received data visible on the computer screen, right? So network layer or the higher layer level layers are able to transfer data over media with the help of the data link layer. So moving toward the last one, and that is the physical layer. Friend, till now we have gone by the sequence from application layer up to the physical layer. So let's revise or conclude it. Data from application layer first has been segmented by the transport layer, placed into packets by the network layer, and framed by the data link layer. So these are the processes that are being done from layer to layer. And now it converts the binary sequence into signal and transmit over local media. So physical layer will convert the binary sequence into signal and transmit over local media. Now it can be electrical signal in case of copper and LAN cable, it can be a light signal in case of fiber optic, and it can be a radio signal in case of air. So signal generated by the physical layer depends upon the type of media used to connect two devices. At the receiving side, the physical layer receives signal, convert it to bits, and pass it to the data link layer as frame. Frames is further decapsulated as data moves to the higher layers, and finally data will move to the application layer. So same the processes that are gone through the application layer to physical layer, it will go in the reverse order from physical layer to application layer on the receiving end. So the application layer protocol makes the sender's message visible on the application in the receiver's computer screen. So in this way, the OSI model is helping to transfer data between distant hosts, or you can say between two different hosts. So friend, I hope you understand this video and it will be informative for you, and don't forget to like it and subscribe to my channel, and we will meet in the next video. Till then, take good care of yourselves.